Okay, you are welcome again to Mathematics Prep. Let's look at the number 4 question. We've done 1, 2, and 3. So today we are going to do number 4. The question is, as on the board, in the diagram, P, Q, R, S are points on the circle center. Our points on the circle, where K is the center. Line KR is a bisector of triangle X, angle XRQ. Then angle KSP is 41 and SKR is 80. So they are asking us to find angle RQP and SPQ. You can decide to mark these angles with any letter of it. Let's look at the first angle RQP. Angle RQP. Let's say this is angle RQP. Let's call it small q. And then the next is angle SPQ, which is this angle here. SPQ. Let's call it small p. Small p. So, from our knowledge of circle theorem, you see that RQPS is a quadrilateral. And whenever you have a quadrilateral inscribed in a circle and the vertices of that quadrilateral touches the circle at the circumference like this, we call this cyclic quadrilateral. And the theorem here is that the opposite angle, which is, let me say this, the whole of this angle and the whole of this angle are supplementary. The theorem states that the opposite angle of a cyclic quadrilateral are supplementary. What does that imply? If I call the whole of this angle here small r, it means that small r plus p should be equal to 180. That's what we mean as opposite angles of cyclic quadrilateral are supplementary. Now this is the angle we are looking for, Q and P. But look at our diagram. RK is a bisector of the angle at R. And RK, if you look at it, since it's running from the center, is the radius. So, and KX is also radius. So, when you bring out this triangle that is inside the shape, like this is the triangle. If you bring out this triangle, we are going to have here to be K, which is the center of the circle. Here is R, and here is X. KS and KR are equal. And here at the center, the angle subtended is 80. Looking at this now, we have an isosceles triangle. So the base angle of an isosceles triangle are always equal. So if here is 80, the sum of the angles in the triangle is 180. You already have one of the angles to be 80. The base angle of isosceles triangle are equal. So the remaining part of this triangle is 100. The remaining angle is 100. So we divide it into 2. We are going to have it to be 50 and here 50. So it then means that this place is going to be 50, and from here to here is also 50. But you know, RK is a bisector of R. Line RK, which is the radius of the circle, is a bisector of the angle, as we are given here, XRQ here. That means if it's a bisector, that means it's dividing this angle into 2 equal parts. That means here also is going to be 50. Now, what do we say? We said that opposite angles of a cyclic quadrilateral are equal. It means that angle, let's say, QRS plus angle SPQ should be equal to 180 because they are opposite angles of a cyclic quadrilateral. So that means they are supplementary. Now we have here to be 100. Is that not what we have? 50 plus 50 is 100. That means the angle here is 100 plus SPQ. Meanwhile, we say SPQ is P, small p, is equal to 180. Then implies that P, which is equal to the angle SPQ, is equal to 180 minus 100. That means the angle there is equal to 80 degrees. 80 degrees. We have answered the second question, which is SPQ. Then the first question, which is RQP, is this angle here. And note, we also said if here is 50, here is 41, that means the whole of this angle is 91. Then angle RSP plus the angle RQP is also equal to 180. Based on our theorem on cyclic quadrilateral, that opposite angles are supplemented. And we have angle RSP to be 50 plus 41 is 91, plus this angle here, which we call small q, which is angle RQP, will give us 180. It then implies that q is equal to 180 minus 91, that is 81 degrees. That implies that the angle RQP is equal to 81 degrees, and you've gotten from that. 89 degrees, 89 degrees, 89 degrees. Alright, thank you and watch out for the next video. May the Lord give you more understanding as you watch.